So as you probably saw in previous podcasts, the vertex form, yeah, it's kind of important because it does give us some information. Yes, the A is still the thing that tells us that it's opening up or down and whether it's wide or narrow. We now know that the C value here is also really important because that's the y-intercept. But it still didn't give us the vertex. So the idea now here is to take this thing, let's go back into vertex form, back into this y equals to the ax minus p squared plus q. Because remember, the p and q gave us so much more information. Maxes and mins, it tells us axis of symmetry, and a couple other wonderful things. Well, we're going to do this very simply by a method called, well, guess what? Da, 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 completing the square. So that's how we're going to do this. Now, the whole idea behind this, in terms of completing the square, is it's a process. As you see over here, it says it is an algebraic process to get it to complete the square. How do we go about doing this? Well, before we do it, I want to set it up a little bit for you. I want to look at this. I want to review this for a second because it's important to see this. Watch. This is a square, right? How do you know? Because it's squared. And you would go x plus 3 times x plus 3. And then, of course, everybody's favorite, FOIL, giving you x squared plus 3x. And look how this suddenly now repeats. Look how that repeats. It's 3x and 3x. That's the neat thing about it being squared. And then finally, plus 9. So if you look at this, this is x squared plus 6x plus 9. That's how I got this mess right here, okay? It's exactly the same thing. But I want to know, is there an easier way to go from here to this because it's a square without even thinking? Well, yes, there is. And it's easy to see it if you look for the pattern. Look, positive 3. This becomes positive 6. So that means the only thing here is this positive 3 was doubled. It was doubled. Why? Because it's plus 3x plus 3x. It's doubled. And then look at this guy right here. Look at the 9. All it is this positive 3 now squared. Isn't that cool? So look, can we go backwards? What if I gave you this? Well, certainly. How did we get this? We got it from doubling. So in fact, I can take this divided by 2. Instead of doubling it, do the opposite because I'm going this direction now. Divided by 2, and I get a positive 3, which we're going to refer to as magic number. Yes. Positive 3 is our magic number. And look what happens if we square the magic number. We get 9. Now, why do I call it magic number? Because look how I even put it in brackets. That's the guy who's going to go right there. There it is. That's how you go backwards. Okay? So always look for a pattern. Let me show you these patterns again. Check this out. Okay, look for the pattern. This is positive 6. Half of positive 6, that's positive 3, right? Magic number. Squared, that's positive 9. So what is this going to look like? This is going to look like x plus 3 squared. Check it out again. This is 8. Half of this, positive 4. Magic number. Squared, that's got to be 16. What's it going to be like? It's going to look like this. X plus 4. The magic number just goes right in there. Take a look again. Look at this one. Uh-oh, this is a minus now. Well, half of that is minus 5, but squared, minus 5 times minus 5 is positive 25. See? But because it has that minus there, making this minus, check out what the factorization looks like. X minus 5 squared. That's how easy it is. Isn't that just incredible? Look at this one. Let's go backwards from this point. That's 49. So before we would do this by squaring. Now we do this by square rooting. Okay, the square root of this is positive 7, meaning, that's the magic number. Okay, double it, that would have to be 14. And this would be x plus 7 squared. Check this again. this number, square rooted, would be positive 8. Okay, squared, or I should say doubled, that would have to be 16. But look, this is a negative, meaning this is now x minus 8 squared. That negative has to go there. So the magic number, in fact, is negative in order to make this a negative. Check it again. Oh, look at this one. 9 over 4. That's ugly. Square root 9 over 4. That gives you 3 over 2. And guess what? It's a negative, so guess what? It has to be a negative as well. There's your magic number. So that would be x minus 3 over 2 squared. But don't forget, we have to fill this guy in by doubling it, okay? So minus 3 over 2 times 2, look at that. 2's cancel, giving you minus 3. That, in fact, is minus 3. There it is. And that's the patterns you have to look at. And when we get into the next little bit here of completing the square, I'm going to show you how to complete the square, take something from standard form, and put it into vertex form. Stay tuned.